Assalamu alaikum, students. Welcome to my very first chemistry lecture on this channel. Chemistry is the science that explains how substances react, combine, and change. Today, we are starting with a very important and exciting topic: reversible reactions and dynamic equilibrium. Just like in life, where some decisions are one way and some can be reversed, chemical reactions can also be either irreversible or reversible. What will we learn? In this lecture, I will explain what reversible reactions are, what dynamic equilibrium means, the conditions required, and give real-life and industrial examples. So, let's begin this fascinating journey into chemistry. What is a chemical reaction? A chemical reaction is a process where one or more substances, called reactants, are changed into new substances, products. For example, hydrogen plus oxygen to form water. In this reaction, hydrogen gas, H2, reacts with oxygen gas, O2, to form water, H2O. This is a chemical reaction because a new substance, water, is formed. You cannot get hydrogen and oxygen back from water easily, so this reaction is considered irreversible. What is a reversible reaction? A reversible reaction is a chemical reaction that can happen in both the forward and reverse directions. Representation. It is represented by the double arrows. General form. This equation means that substance A reacts with substance B to form products C and D, but those products can also react with each other to form A and B again. The double arrow shows that the reaction can go in both directions. Forward reaction. A plus B to form C plus D. Reverse reaction. C plus D to form A plus B. For example, nitrogen gas plus hydrogen gas to form ammonia gas. This is a reversible reaction known as the Haber process. It's used in industries to make ammonia, which is very important for making fertilizers. What are the reactants? Nitrogen gas, N2, comes from the air. Hydrogen gas, H2, usually comes from natural gas or water. These gases are combined under high pressure and temperature, using a special iron catalyst. What is the product? They form ammonia, NH3, a colorless gas with a strong smell. Why is this a reversible reaction? Because ammonia can also break back into nitrogen and hydrogen. That's why we use the double arrow, which means the reaction goes forward and backward. Real-world use. This reaction is done in factories all over the world to produce ammonia for fertilizers, which help crops grow. Now we move to dynamic equilibrium, so what is dynamic equilibrium? Dynamic equilibrium is a state in a reversible reaction where the rate of the forward reaction is equal to the rate of the reverse reaction. The concentration of reactants and products remains constant. The reaction is still happening in both directions, but there is no net change. It is called dynamic because reactions are ongoing, and equilibrium because their effects cancel each other out. Conditions for dynamic equilibrium. Closed system. No substances are added or removed during the reaction. Constant temperature and pressure. The reaction must be reversible. Factors that affect equilibrium. If a system at equilibrium is disturbed, it will adjust itself to oppose the change and restore equilibrium. Main factors. Concentration. Increasing concentration of reactants pushes reaction forward. Temperature. Raising temperature favors endothermic direction. Pressure for gases. Increasing pressure favors the side with fewer gas molecules. Example. In the Haber process, increasing pressure favors the production of ammonia, fewer gas molecules on the product side. In summary, reversible reactions can proceed in both directions. Dynamic equilibrium is when forward and backward reactions occur at the same rate. Irreversible reactions happen in one direction only. Equilibrium occurs in a closed system under stable conditions. I hope everything was clear and easy to understand. That's all for today. Don't forget to like, comment your thoughts and subscribe for more videos. Allah Hafiz and see you in the next lecture.